Welcome. Today we're going to review some right triangle trig from geometry. So we already know how to draw reference triangles and reference angles, and we're going to look at today how we can find segment lengths, ordered pairs, and angle measures. So without further ado, here I have just a general right triangle. These sides really don't matter what I call them, but I do need to reference on a right triangle. I do need to understand which one is the side opposite the hypotenuse side. So Pythagorean theorem is going to be useful for determining sides when we're given other two sides. So what we need to understand is that in this case, if I'm labeling this A, B, and C, and Pythagorean theorem is A squared plus B squared plus C squared, that C that I'm calling is always going to be my hypotenuse, which is going to be directly across from my right 90-degree angle. The other two sides, they don't really matter. They're just not going to be, so your hypotenuse will always be isolated by itself, whatever you want to call that. You can call that, instead of C, you can call that a smiley face. And either way, if that's smiley face, he needs to be over here by himself. Although he might be a frowny face if he's by himself. Okay, let's look at some examples. Here we're asked to find OP. So what is OP? OP is going to be this line segment right here on that terminal side. So to do that, I'm going to draw a reference triangle. So from that point 3, 6, I'm going to construct a triangle. Now I have a right triangle, and I'm going to find OP. So if this is the point XY, I'm going to go ahead and label the sides of this triangle that represents. So if this is the X coordinate along the X axis, that unit will be 3. I'm always going to write, you'll see as we go through these, I'm going to always write when I'm labeling the sides of the triangles, I'm always going to write those as positive values, even if the ordered pair might be negative. And that's because I'm talking about the length of this triangle. So, and length will always be positive. That y is going to be 6. And so if I'm asked to find OP, that's asking to find the hypotenuse. So I'm going to use Pythagorean theorem to do that. For the purpose of this unit, O will always be our center, and OP will be our hypotenuse. So there's OP. I'm going to use Pythagorean theorem. 3 squared plus 6 squared equals OP squared. That's 9 plus 36. I get 45, and then to solve for OP, I need to take the square root of both sides and get approximately 6.71 for OP. Another example, here we have a triangle that's the terminal sides in quadrant 2. So I'm going to label these. Even though X is negative, I'm going to label it as positive on the length for X, because that's the side of the triangle. The side of the triangle is not going to be negative. And then that's going to be 3. I'm also asked to find OP again. So I'm going to set up my Pythagorean theorem to do such. 16 plus 9 is OP. If I take the square root of 25, I just get 5. Here I'm not asked to find OP, I'm given OP, and I'm actually asked to find X. So if we notice, the value for X in the quadrant 3 is negative. It will always be negative, because as we go over here, like if I ask you to sketch the point negative 3, negative 1, you would go 1, 2, 3, and then down here, and we'd be down here. And that's because this is negative, and then the y is also negative. So let's construct that triangle. This is going to be my x. There's my y value coming from my ordered pair that I was given. And then my OP was given to me in the problem as 6. So I'm going to set this up. This time, once again, like I said previously, my hypotenuse side always needs to be by itself. So I must write this. This is not 6 squared plus 5 squared, or 5 squared plus 6 squared. That hypotenuse side always needs to be by itself. So that's 25 and 36. I need to get x squared by itself, so we need to subtract 25 from both sides and get x squared equals 9. We take the square root of both sides, and we get x equals 3. However, we do need to consider what quadrant we are in, determining the sign of the x and y values. Since we're in quadrant 3, x will be negative, so this is going to be x equals negative 3. Same idea here. We're going to construct a triangle. Now we're in the fourth quadrant. Here, x is always going to be positive and y will be negative. An example of that is if I ask you to sketch, let's say, 5, -2. We would go over 5, 1, 2, 3, 4, 5, and down 2, 1, 2, and we'd have a point there. So let's go ahead and construct this triangle and label what we can. So that's 7. My hypotenuse is 10. So once again, the hypotenuse should be by itself. I'm trying to find what y is, and I should understand that y is going to be negative. So I have 49 plus y squared equals 100. Subtract 49 from both sides, and I get 51. Take the square root of both of those, and we should get 7.14, but it's negative because I am in the fourth quadrant. Okay. You may have recalled this term SOHCAHTOA. What this represents is your trig, or 3 of the trig functions, sine, cosine, and tangent. And this is just kind of a way to help you remember what it's talking about. On a right triangle, we have, or any triangle, we have 3 sides. A right specifically has a hypotenuse side, only for right triangles. And then the other 2 sides are called opposite and adjacent. And that is based off of the angle that I'm referencing. So if I'm talking about this angle right here, this side is opposite of that angle, and this is the adjacent side of that angle. So it's the non-hypotenuse side that touches that, it's the side that opens up that angle. So that side and the hypotenuse open that up. The opposite side would be across from that angle. So the sine of theta, that SO part, SOH, helps us to remember that the sine of something is going to be opposite over the hypotenuse. The SOHCAH, that helps us to remember that it's adjacent over hypotenuse. And the TOA is for our tan, which helps us to remember that it's opposite over adjacent. I also have this other triangle up here just so we can understand, like we're only going to be dealing with one type of reference angle, and it's going to be in the same place every time. But just so we kind of understand the adjacent and opposite sides, if I'm looking at this angle up here that I have labeled, the opposite and adjacent side have changed because the angle I'm talking about has changed. So that's still our hypotenuse. That's opposite of the 90-degree angle. But now the opposite side that I would call opposite would be down here because that is the opposite side of that angle, and the adjacent side would be right here. So that is kind of looking at it from that standpoint. Okay, so here we are given a point on the terminal side of theta and an angle in standard position. Find the exact value of sine, cosine, and tangent of theta. So all we're going to do is simply write out that SOHCAHTOA using these values. So I'm going to start by doing this. Determine the quadrant by the ordered pair. If you were to plot this point on a graph, where would that exist? That should exist in the first quadrant. Both of your values are positive. We'd go over 5 and up 12. So that should be in quadrant 1. Then we're going to construct a right triangle on the terminal side in standard position. So something like this. It doesn't have to be exact. I'm going to go ahead and label that point 5, 12 on here. And then I'm going to go ahead and label all the sides of the triangle. So that x value is 5, the y value is 12. So I'd need to find the hypotenuse. So I'm going to use Pythagorean theorem to do that. And I get 5 squared plus 12 squared. Add these together, get 169. Take the square root of both sides, and we get 13. So that is our hypotenuse. Now this is just using the SOHCAHTOA to write this all out. So SOHCAHTOA says that the sine of an angle is equal to the opposite side over the hypotenuse side. So I can write that as the sine of that angle is equal to, well, what is opposite of the angle? Opposite of this angle that I'm referencing is the side length 12. The hypotenuse is 13. That's where that comes from. The cosine is the adjacent of that same angle, so 5 over the hypotenuse, which is the hypotenuse. And then tangent would be opposite of the same angle we're talking about, which would be 12, over our adjacent side, which would be 5. So this is what I'm referring to. If you're watching this video for the first time, I would encourage you to try to stop and do maybe the next one on your own. The next one's going to be the same, but we're going to run into something that it's like I'm not going to be super nitpicky about, but a lot of math teachers are. So we're going to talk about what's called rationalizing the denominator. So think to yourself when you're sketching this, what quadrant that's going to be. If you had to plot this point, we would go -2 and up 4. So we'd have a point here. That's in quadrant 2. So when we sketch this, we're going to sketch this in quadrant 2. Here's our triangle. It doesn't have to be exact. I'm not going to go and like do those little tick marks like I did a second ago. I'm going to go ahead and label my point up here, and then I'm going to label my side for my x, which would be +2 and +4. I'm not making this, once again, I'm not going to make this a negative right here, even though that's in the negative direction, because I'm working this triangle, and this 2 is representing a length of a triangle. So if I ask you what is x, then we're going to be referring to the ordered pairs. So x and y can be negative or positive, but the sides of the triangle will always be positive. Okay, let's find that third side by doing what we just did. So here we get c equals the square root of 20. I'm going to leave it like that, and I'm going to go ahead and fill in my exact values for the sine, cosine, and tangent of theta. So here in quadrant 2, looking at my reference angle, sine is opposite. So opposite, the opposite side over hypotenuse side. So I would be 4 over the square root of 20. And here's how it looks kind of different. So I'm going to do this, and I'm going to show you, and I would prefer that you do this. To be honest, at this point, I don't think that we're going to be grading on the rationalizing your denominator, but this is what that essentially means. You don't leave a square root showing in your denominator. So the way we do that is we just multiply by whatever the square root is, the radical in the denominator, we multiply by that over itself, because we don't want to change the value of anything. So I'm going to do this, and what that is I'm really just multiplying by 1 because I have a number by it over itself. But what that allows me to do is, first of all, it keeps the value preserved, like so I didn't change what I have. And now when I multiply this, what happens to the denominator? Well, what's the square root of 20 times the square root of 20? That's the same thing as doing the square root of 20 squared. Doesn't squaring a square root undo the square root? Yes, it does. Just like when we're trying to undo that, we would square it so that this would just equal x. So I'm going to go ahead and write this down. I would have 4 times the square root of 20 over 20. And then I also can reduce this fraction here. So we don't want to touch what's inside the square root. We don't want to touch that, but I can reduce these. Both of those can be divided by 4, and I would just get the square root of 20 over 5. Same idea for the cosine of theta, rationalizing our denominator. We get down to something like the square root of 20 over 10. And then when we do tangent, tangent is the opposite over adjacent, which is just 4 over 2, looking at our triangle. The opposite side over our adjacent side, that would just simplify to 2. Okay, we're going to use SOHCAHTOA to actually find ordered pairs now. So not looking at exact values for like what we just did, but here I'm going to give you part of an ordered pair and an angle, or maybe both points, and we'll find an angle. We'll do kind of all of that stuff. But here we're given a point 3y, and we're given our angle theta is 70 degrees, and we want to find y. So first, let's see if we can determine what quadrant we're in. We've already talked about where 70 degrees lies in last unit. That would be in our first quadrant. So quadrant 1 is where we should be. We're going to go ahead and kind of do what we did last time. We're going to make a right triangle in that quadrant. And then I'm going to go ahead and label what I can. So fill in my information. So I'm going to label my point up here, 3, y. I don't know what y is, so I'm just going to leave it as y. I'm going to label this side of 3, and I'm going to label this, what I'm trying to find, as y, and also my angle down here. So now I have my angle. I know what my angle is. It's 70 degrees. And so from here, I'm going to I need to understand I'm trying to find y. That's all the information I know. But I can use SOHCAHTOA to find that information. So what I need to consider here is, with respect to this angle that I'm given, what two sides do I have showing? Well, y is what I'm trying to find. This is what I'm given. So let's understand what those two sides are called with respect to this angle. That's opposite, and this is our adjacent. So we need to have some type of an equation where we set up where we have an unknown, and then we have information that we're given. So which one of our trig ratios uses opposite and adjacent? That would be our tangent. Tangent is opposite over adjacent. So this is how this would look. We would take tangent of the angle, theta. This is always going to, that number inside of here is always going to represent an angle, never a side. So we would say tangent of theta equals y over 3, opposite over adjacent. And then to solve for y, just like algebra, when we isolate something, we have 3 that's dividing y. So to undo that division, I'm going to multiply both sides by 3. That would cancel this and leave me with just 3 tangent of 70 equals y. We do need to make sure, we haven't talked about this yet, but we need to make sure that we are in degree mode. There's 2 modes on your calculator, degree and radians. Since we're dealing with degrees right now, we need to make sure we go into mode, scroll down to where it says radians and degrees, select degrees and hit enter, and then second quit to get out of that screen. And anyways, now I can type in 3 tan 70 in my calculator exactly as that looks. So just 3, you can do 3 times, or you can just do 3 tan. So if you type in 3, then tan, then 70, we should get approximately 8.24 is our y. All right, let's try another one. Using SOHCAHTOA, find ordered pairs. So here we're given our hypotenuse of 20, our OP, our degree of 38, and we're asked to find x. So let's go ahead and once again, we're in the first quadrant. 38 degrees is in quadrant 1. So let's make a right triangle in quadrant 1. And then I'm going to fill in my information. So I know that the angle theta is 38 degrees and my hypotenuse is 20. All right, now we are looking to find the x value. So I should be looking at, with respect to this angle 38 degrees, that's the adjacent side is side x. The side that I know is the hypotenuse. So we can use SOHCAHTOA. Adjacent and hypotenuse would be cosine. So I can set that up, sine of 38 degrees equals x over 20. To get x by itself, we can multiply both sides by 20 to cancel the 20s, and then we can type in 20 cosine of 38 into our calculator, make sure that we're in degree mode, and we should get about 15.76. All right, here we're given a point. We want to find angle theta. Let's figure out what quadrant we would be in. If I had you plot this point, right, we would go over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and we'd have a point right there, somewhere around there. So that quadrant, that's in quadrant 1. So we're going to start by determining that quadrant. We're going to go ahead and sketch our right angle. We're going to fill in what we know. So I know that that point is 6, 6. So I'm going to go ahead and label that side as 6 and this side as 6. And then I'm going to pay attention to what I'm asking to find here. So here I'm not given an angle. We're asked to find that angle. So we're going to use SOHCAHTOA based off of the sides that I'm given. Opposite, I'm trying to find the angle. So the opposite side is 6. The adjacent side is 6, so I can use both of those. Opposite over adjacent would be tangent. If I can set that up, I can go ahead and reduce this to tangent of theta is just equal to 1. And now what do we do here? So this is, we're asked to find theta. We're not asked to find tangent of theta. Now we've had problems where we've expressed something, the exact value of a side by using trig ratios, but here I actually want to know what that angle is. So can we use Pythagorean theorem here? I need to respell find for what we're looking for. No, because we're not looking for a side. I mean, we can use Pythagorean theorem, but that's not going to help us at all. So let me just kind of quickly review, or let's talk about real quick what our objective is. Our objective is, if I'm asking to find theta, that means I want to see this and only this on one side of the equation by itself. In other words, I want to get rid of this. And this is not tangent times theta. This is the tangent of theta. So I need to undo tangent, but it's not multiplication. So let's talk about what that looks like. Alright, so here I have some problems that all of us should be able to do at least the first four, and we should be able to do the last two as well. Let's just talk about what it is we're doing here, and this is just kind of to illustrate a point. Here we have x plus 7 equals 9, just a basic one-step equation. How would I undo that? I would subtract 7 to both sides, and I would get x equals 2. Notice here, I'm doing the opposite operation of addition, and I'm showing it on both sides of the equation. Okay, same thing here. X minus 7, opposite of subtraction is addition. I'm showing that on both sides. And then I bring this down, I show what cancels. Here I'm going to do the opposite of something being squared, which is the square root. Showing that on both sides, and we get x equals, and then this is actually plus or minus 3. The opposite of something being square rooted is to square that thing. So what I want you to pay attention to as we're doing these is we're always doing the opposite at some point in an algebraic equation because we're trying to solve for an unknown. So eventually we end up doing an inverse operation, the opposite operation to isolate that thing, depending on what is surrounding x. Here we have a log. If you guys recall from our first unit, the opposite of log is an exponential, and the way that looks is by exponentiating both sides. So we make that big number to basically look like it throws whatever was there up in the exponent. That would cancel those, and we're left with x equals 10 squared, which is just 100. Here, the opposite of an exponential is a log. These are opposites of each other. So I can say the log of 10 to the power of x equals log of 100. And remember, this base, when it's not written as 10, that cancels those. X equals log of 100. Oops, I should say what that is. And that's just 2. So once again, what I do to one side, I do to the other. What I'm doing is the opposite operation. I'm going to show that same thing with undoing a trig function. So we're going to look at these few trig functions just to see what that looks like. Now, we don't necessarily have to show this every time, like the undoing part and the canceling, because it just kind of gets repetitive, but I wanted to show that just so you can see, because this looks a little bit differently, kind of like when we first look at what exponentiating looks like, or taking a log of both sides look like. That was new, so I wanted to show it to you. So here, looking at sine of theta equals 1, I want to isolate this. So how do I do that? Well, I need to undo the sign. So to undo the sign is just the sign inverse, and it looks like sine raised to the negative 1. So what I would do to both sides is, this is me showing the inverse of both sides. So this is doing the opposite operation. One side is going to cancel and get what I'm trying to get by itself, and then I bring this down. This side I would type into my calculator, and I would say, ooh, that's 90. Same thing on the cosine. I would do the opposite operation on the cosine, cancel the cosines on the left, giving theta by itself, type in the inverse cosine of 1/2 in my calculator, and I would get 60 degrees. The one we're doing, we'll go ahead and do it here so we don't have to do it here in a second, but on your paper, we have the tangent of theta equals 1, so I would do the inverse of both sides, showing this canceling out, and now I have theta by itself, so I can type in the inverse tangent of 1. And to do that in your calculator, you're just hitting, like we have sine, cosine, and a tangent button in our calculator. To do the inverse, we just have to hit the second button first. So if you look above sine, cosine, and tangent on your calculator in blue, small above that button, it will say sine to the negative 1, or cosine to the negative 1, or tangent to the negative 1. That is the inverse. So we just have to hit second tangent of 1, and that will give us our answer. So our answer here should be 45 degrees. Now, it's not necessary that we show this step that I just showed right here all the time. Like, if we're right here, the next thing that we can write down is just simply this. And then that just equals 45 degrees. So we don't have to show this canceling, but I just want to illustrate why we're doing that, why it looks like that, because this is the opposite operation. This is not, tangent is not multiplying to theta. That is the angle. Okay, here we have one where my animations are already showing, which it shouldn't be, but that's okay. We're going to start by determining the quadrant. So 220 degrees, y equals negative 12, theta is 220 degrees. Find OP, so I'm going to be looking for the hypotenuse. So if I go all the way around here, that's 180 degrees. If I go all the way here, that's 270. So I should be in quadrant 3, because 220 degrees will end up in quadrant 3. So we're going to draw a right triangle there. We're going to label what we can. I have y equals negative 12, but I'm going to label that as positive 12 on the triangle side. The ordered pair, I'm going to label that negative 12. And then also I'm going to go ahead and label my x as negative, just to help me remember that that will be a negative number, because in quadrant 3, excuse me, x and y are both negative. Okay, so now that I have this, given an angle of 220 degrees, let's figure out what that reference angle is, because we are trying to find this. That angle is not 220 degrees, but we can do that. Recall how we can ask ourselves, how far away from the x-axis is 220 degrees? Or more so, how far is it away from 180 degrees? And we would say that that's 40 degrees. So now that I have this, I'm going to look at my given angle of 40 degrees. The opposite side I have is 12, and the OP, what I'm trying to find, the hypotenuse, is what I'm trying to find. So with respect to the angle, I have the opposite, and I need to find the hypotenuse. So opposite, we're going to use opposite over hypotenuse, which would be the sine. Setting this up, this one's a little bit different only because now what I'm looking for is in the denominator. So I need to first, this is kind of like a little more steps involved. I need to first get that out of the denominator. So to do that, I can multiply both sides by OP, and that will just bring that on the other side. We'll cancel it over here, and now I have OP times the sine of 40. So let's rewrite that, see what that looks like. Okay, now we have OP times the sine of 40 equals 12. To undo that multiplication, I'm going to divide both sides by the sine of 40. That's going to cancel these. And now I'm going to rewrite this just so we can kind of see what it looks like, because often students will say, well, what do I type into my calculator? Well, once you get what it is you're trying to get by itself, which is OP, and OP is by itself, this is what you type into your calculator. How do you type that in? Type it in as a fraction. Alpha y equals enter. Get this little box like this. Type in 12 up top. Type in sine of 40 in the bottom. And hit enter. And we should get about 18.67. All right, so that is the day 1 of this Unit 8. You have problems 1 through 10 on worksheet 8.1. Please make sure you're asking questions as you have them and checking the solutions on Canvas.